Okay, we're going to start at the top of page 4. We are going to look at how to find the percent change. You guys are going to use this handy dandy formula for percent change. A lot of times I will also write it as F minus I over I. That kind of makes it a little bit shorter. The biggest thing that you want to do with this is be careful that you are dividing by the initial amount. You do not want to divide by the final amount. Starting with example 7, it says, oops, sorry, it automatically scrolled. It says a state's health department is tracking the number of positive test results for a virus. Wow, this sounds like so unfamiliar. In an urban county in the state, the number of positive test results per day increased from 115 to 145 in one day. In a rural county in the same state, the number of positive tests results per day decreased from 55 to 40. Calculate the percent change in each county's number of positive test results, rounded to the nearest whole percent. So let's go ahead and first do it for the urban county. The first thing I want to make sure that we do is state what was the initial amount and what was the final amount. So the initial amount was 115 and the final amount was 145. So if we use our formula of final minus initial divided by initial, we have 145 minus 115, and make sure that you're dividing it by that initial amount, 115. So we get 30 over 115. If we divide that, we get 0.2608, and we're going to change it to a percent. So this would be 26.08. It says to round to the nearest whole percent, though. So that's going to be about 26%. For the rural county, their initial amount was 55. Their final amount was 40. So if we do final minus initial divided by initial, we have 40 minus 55 divided by 55. So we're going to have negative 15 divided by 55. You may be a little perplexed why we have a negative here, but remember that the rural county is decreasing their test results. So we should see a negative with that. So we get negative 0.2727, and if we change it to a percent, we get about 27%, and this would be a negative 27%. So you can write it as negative 27%, or you could say it's a 27% decrease. You want to have it either be negative 27% or include something that implies a negative, like the word decrease. Gertrude started a diet. Her starting weight is 200 pounds. In January, she lost 10% of her weight. How much did she lose? So we want to find 10% of 200. So we're going to change 10% to a decimal. So 0.10 and multiply it with 200. So how much she lost is 20 pounds. For part B, it says, what is her new weight in January? So after that 10% weight loss. So let's take away 20 from 200. We get 180 pounds. Part C says, March was a hard month for Gertrude. She gained 10% of her body weight back. How much did she gain back? Now, it's gaining 10% of her new body weight back. So we want 10% of 180 pounds. So that's going to be 0.10 times 180. So we get 18 pounds. So for part D, what's her final weight? So if she gained the 18 back, we are now at 198 pounds. Is her weight back to the original weight? Why or why not? So these do not match. Oops, sorry. There we go. The 200 and the 198, they do not match. And the reason is even though we had a 10% loss and then a 10% gain, we were looking at 10% of two different numbers. So this is, she is not, because this was 10% of two different numbers. So it did make a difference. Okay, example 10. This is your last problem for this section. A husband and his wife are working together to lose weight. After the first week, they weigh in and compare their results. Fill in the table. So the husband's starting weight is 380 pounds and his ending weight is 366. To find the pounds lost, we can just subtract those two. So for him, we have 14 pounds lost. For the wife, we can do the same thing. Her starting weight was 200 and her ending weight is 190. So if we subtract, she has 10 pounds lost. To find out their percent of weight lost, we can take their amount of weight lost divided by their original amount. So for the husband, it's going to be 14 divided by 380. 14 divided by 380 is 0.037, or about 4%. For the wife, hers is 10 out of the original 200, which is 5%. And it shows up in the calculator as 0.05, which would then be 5%. So the husband lost 14 pounds and his percent of weight lost was 4%. The wife lost 10 pounds and her percent of weight loss was 5%. So part B, using the information from the table, determine which of the following are true. For I, the husband lost more pounds. That's true. He did lose 14 pounds, whereas the wife lost 10. The second one, the wife lost a higher percent of her weight. She lost 5% of her original weight. He lost 4%, so she did lose a higher percent. That is true. The wife's new weight is 95% of what it was originally. So she lost 5% of her original weight, which means that she has 95% of her original weight because she only lost 5%. So yes, she is at 95% of what she was originally. And the last one, it says the wife's starting weight is 5% more than her ending weight. So if we take 5% of her ending weight, 190, we would find that 0.05 times 190 is 9.5. And if we added that to the 190, it's not quite at the 200. So this one does not work. And that's just like the other problem that we did, where we can't lose 5% and gain back 5%. It's not going to end up canceling each other out because they are 5% of different amounts. So just like if you can add 5 and subtract 5, you can do that and start back where you began. But you can't do that with percents. Okay, that sums up everything for section 6. I hope you guys have a great day.